They don't present with this is just the things you said.
I was on track for the 19th, for the 21st.
I don't know. I'm not confident for CB. I'm confident for all the others, but that one is just.
Yeah, well, you two are rich.
Yeah.
Alright. No, it's not. Oh, yeah, I do.
Does everyone have a copy of the notes? Most of you do, I can see that. Well, I have an express here, so, yeah. Seems like 70% collected, right? So, quite certain what attendance would be like.
Can I get a copy of this first?
Right, so you have the course outline on the first two sheets, and then the notes. So while since I've used a chalkboard, but I have to say that I prefer these, although there is some amount of dust. So my name is Shubir. This is monetary economics. Few general pointers before we start. My office hours, as mentioned on course outline, this term will be on Tuesdays between 11:30 and 1:30. Okay, you're of course welcome to get in touch at any other time. We can organize a meeting. It is important that you make use of office hours. I've observed that over the last 2 or 3 years, possibly because of recordings, students seem to think that there is no need to attend office hours, that anything that they haven't understood, the easiest way out is just make sure that you memorize everything and you will be fine. In this class, you won't fail, because I try to make sure nobody fails, but you will be far from doing as well as you're able. So please come and speak to me. You can ask me questions at any time during the class, and you can ask me questions during office hours, anything that is not clear, it's best for you to clarify it. On the web, it still says my office hours are on Mondays, because that's the way it was set up last semester, but I get that changed. So Tuesdays, 11:30 to 1:30, that's the first thing. Second is, I'm going to try and start at 5 minutes past, and try and end 5 minutes to the hour. Okay, so that's what I'm going to try and do. I'll try and see if I can make sure that I'm here a bit earlier than that. I might be late sometimes. If you haven't been informed, it means the class will be held. I'll try and make sure that I'm not late. Okay. I will be taking attendance in class. That reminds me, the thing that I will tend to forget is to give you the code. So that someone would have to remind me about. I do have the code, but I've forgotten. So the code for today is 829262. And there's a sign-up sheet that I will pass around before every session or during every session. I request you to please put down your name. This way, I will have a simple way of keeping track of who's been attending, who hasn't. Okay, it's of course not obligatory, but it would be useful if you were to do that. So this is, as I said, monetary economics. I will have a little bit to say about the module. If you have any questions, you can ask now. But in general terms, it's of course a continuation of what you've learned in your first and second year. You've seen material in both macro and micro. You've seen material that has to do with the role of money, aggregate demand and supply, and the central bank and all of that. It might have been pointed out to you that I would say none of those models, certainly the vast majority, stand up to scrutiny when you look a bit more carefully about the role of money. Some of the other things just collapse. This is a critique that's usually made of Keynesian models, but it's also true of the older style non-Keynesian models, whatever that means, classical models. So what we will be doing is we are motivated by the macro questions, because if you don't really understand how the model works, your policy implications are also very weak. Okay? So we will try and make sure that we construct models which have micro foundations, so that you're actually able to build things up from the basics. That does mean that you won't be able to do very much, okay, because it gets complicated very quickly. But you will get a feel for the sorts of problems that crop up, and we will have a few answers. Okay, talk about that perhaps a little later today, and then of course as we proceed through the class. Now in terms of the module and the material, there is some reading. So the first thing to note is on the third page, it gives you a tentative lecture schedule, which is actually something that I follow quite closely. Okay? So it tells you what topics we will cover and how. And there are some references at the end, which you're welcome to look at if you wish to. The notes have been circulated. There is also a PDF available on the VLE page. I strongly suggest that you carry the copy of the notes that I've circulated with you to class. You can look up the material before you come. You certainly need it while I'm teaching. And then you would, of course, want to look at it later once you've attended the lecture. The notes are very terse. Okay? That's because it's not a textbook. I have no plans of writing a textbook of any sort. So these are notes based on other sources, typically very sound sources, which have lots of other details, technical details, which would not be appropriate for a class of this sort. But the notes are self-contained, and whatever technical details are required are provided. And I will go over them in class. Okay? You will do the additional reading if you wish to. Sometimes the reading is not optional, and I'll mention that when that's the case. Right. There are no figures in the notes, but I will be drawing figures on the board. I will not write everything out on the board. Sometimes I will write more and sometimes less, but that's because the notes are there for you. It's also not the case that I will only be storytelling in class. The idea isn't that I just stand here and chat a little, or sit on my chair and chat a little, and then you're required to read the notes and do all the hard work. No. You have to do the hard work, but I will be going over the material in class, so you will be taught everything. Is that okay? Now, there is a fair bit of maths here. I should say a lot of maths. So you have to be clear that you enjoy maths, that you are fairly good at it. Okay? If nothing else, you're open to an abstract way of thinking, and you're willing to learn. The better you're at it, the better you will do on the exam. So don't take this class because you think you'll do really well to make up for the fact you haven't done well in other classes. That's a very bad idea. Take this class if you're interested. Whether you do well or not is a separate matter. Certainly hope you do it. Okay? There are 19 lectures that have been planned, and I tend to use almost all the time. In addition, there are 8 problem-solving sessions, and the problems are an integral part of learning the material. And that means you need to work on the problem sets on your own before I work them out on the board. Don't expect to be able to solve the problems. Maybe some of them are part of it, maybe some of it a little more, but you need to try, because otherwise it will be pointless for you to sit and see the solutions. You need to have tried to realize where you got stuck and how to get around it. Is that okay? So you must make an effort at working out the problem sets, and that does not mean 15 minutes the day before the problems will be discussed. You need to give yourself enough time. See, pretty demanding, and you won't find solutions to these essentially anywhere on the web unless there are copies of past solution sets of mine that students have hoarded, which would be a terrible idea. Okay, so the problem sets are an essential component of the way I teach. There will be material there, as I've just said. Most of it will not be repeats of what you've seen in class. It's not that I'll work out an exercise in class, change the numbers and give it to you on the problem set. That's not the way it works. It's based on the material that you were taught, but you will have to work it out on your own. And of course, you'll see what's the correct way of doing it. All right? There are two pieces of work that you will have to hand in. So there will be a specimen paper, and solutions to the specimen paper will be posted right at the end. The first bit of work will have to be handed in sometime during the middle of the term. The exact weeks, etc., are on the course outline, and that will be one half of the specimen paper. That will be coursework that I will mark, and that will count towards your mark, 10%. Okay? And the second bit will be handed in right at the end. Since there is no mark for it, in some sense it's optional, but I strongly recommend that you do it. And again, I will mark it and return it to you. The reason only one is going to count for your mark is because we were told that the assessment burden is too great if you have two, which is the way it used to be last year, the year before, last year. We were first encouraged to have lots of elements of these things, which I always had in the class, but then to make them count for the mark if possible, I did, and then there was a pullback on that. So I will be marking the work if you have it. Is that okay? There will be 2 seminars during which I will be discussing the work that you've been asked to hand in, together with any other questions that you have. Right? Anything else? I don't think of much more that I need to add. As I've already said, please make sure that you attend. Please make sure that you do your work diligently. I hope you enjoy the class and ask questions and stay up with the work. There are people in the past who've taken this class, who didn't attend lectures, who came and would ask me questions during the last 3 weeks before the exam. Some of them did well. I'm not going to tell you that none of them did well. Some of them did well. But I don't think it was worth the trouble. After all, I'm teaching, so you don't have to do that on your own. Okay? Anything else that you'd like to ask before we start? So, there'll be notation. Much of it might not be familiar to you, depending on what your backgrounds are. It's listed on the notes, and anytime you have a question of any sort, you need to ask. Now, we are not going to even come across the term money for quite a few lectures. Okay? Why is that? It's because in order to understand the role of money, we need to work with a structure which is completely clean. And that structure is best understood in the absence of money. So we'll start there. Okay? And then we will, of course, have to modify that structure in some form or the other, or modifications include extensions, which will allow a role for money to appear. Once that happens, we will see that it depends on precisely how that role is modeled, and we will have implications for policy. Not a lot, but at least enough to tell you that simply nodding when some analyst tells you something is probably a bad idea. Because most of the time, we really don't know what the answers are. Ask yourself a simple question. Why has the Bank of England set the inflation rate target at 2%? I've never understood this. Why is it 2%? Why not 2.5%? Why not 16? Why not 1? Why not 0? Why? And I won't be able to give you an answer to it. It's just to tell you that once you start thinking, there are all sorts of things about which we actually don't have an answer. We don't have an answer because those models really aren't very clear. And they're not clear because of the way they've been set up so that they're simple. But simplicity has its cost. So how is policy determined? Well, you would hope that there are trained economists who have an intuitive grasp for what is happening. Okay? So that intuitive grasp, of course, comes from understanding some deeper level, which is what I hope you pick up with this. All right? So we are going to start by looking at a very simple framework which comes from micro. All our tools will come from micro, including game theory. We'll do a little bit of economics with asymmetric information right at the end. So there the tools will come typically from game theory. But for most of the class, our tools will come from something called general equilibrium. So I'm going to start by telling you a little bit about general equilibrium. So we're going to look at two-good, two-agent economy, which can be put together in an Edgeworth box. You've probably heard of the Edgeworth box. The Edgeworth Bowling box? No? Not in micro? My goodness. All right. The first thing used to be gone. So hopefully you will learn a little bit. Good. I also have a chat with people who do micro now. And I'm sure they'll tell me that you have been doing this. All right, well, let's see. So, for those of you who like to read, there is a very nice book by Edgeworth. Edgeworth, like many economists, not all, but many economists, was a mathematician, physicist. In fact, much of his approach was using differential equations for understanding economics. And he made some very important contributions to economics. And the name of the book is Mathematical Cycles. It's a fairly short book by standards of academic writing, even modern academic writing, but it's a very nice idea. He develops the notion of something called a chord, which is a very important concept in game theory. Okay? Because he never named it. That name came about 70 years later due to Gale and Shapley. But the concept is due to Edgeworth. At that time, Walras was talking about his auctioneer. So Edgeworth came up with the basic questions that many of you would have had. Where is this auctioneer? We don't see an auctioneer. So how do you come up with a market solution? And Edgeworth said, well, groups of people interact. And the solution that they will find is the one that would, with many, many agents, become the same as what the auctioneer would find. Okay, so it's a nice thing to read if you want. Anyway, so we have two goods, okay? You can call them apples and bananas, A and B. The key requirements are that the goods are physically distinguishable. Just two. Okay? We will generalize later. For the moment, you know which is an apple and which one's a banana. Those are the only two that you have. And they're perishable. So this economy will operate for just one period. There is no tomorrow here. For the moment. So I'm not writing that down. They're physically distinguishable and perishable. And technically the important thing is that you can consume these goods in any number which is a real number. Okay? So in terms of what we have in mind, we will simply think of an origin, quantities of apples on this axis, XA, or all those apples that we call X1, because A and B will denote agents, and X2, and any point that I pick on that white line, or any point that I pick on the other white line, would be a real number. I'm not defining real numbers or anything like that. But since we will be doing calculus, it's important for us to make clear as to what the structure is. That's why we do it, in case you're interested. So they're two goods, and you can consume them in quantities that are non-negative towards the right here and upwards there. So any region in the area that I've marked. And that's a real number. Okay, so that's the physical description of what we have. What about individuals? Well, you have two agents, A and B, and each of them will enter the economy with a quantity of each good, which we denote by omega 1 A, omega 2A, and similarly for B. For the moment I'm doing everything for agent A. So these quantities are the quantities of apples and bananas that agent A enters with, which gives me a point. Okay. Now, in order to proceed, we need to say something about who these agents are. I've told you what they bring into the economy. I also need to tell you what they'd like to do, in other words, their tastes. So we're going to assume that tastes are nice, by which we mean that given any point over here, it's called a consumption bundle. So given any point, if I give the agent more of either of the two goods, the agent is better off. So you like more rather than less. Okay? The second is that when I consider points that are indifferent, the line that I get curves so. This is an assumption of convexity. Okay? So if I take 2 points that are just as good, any point that is between the two is also at least as good. I'm not writing this out formally. Okay? So that's the sort of line we get. There is a market for each good. Now the market will be competitive by which over here we mean that there is a price P1 and P2, both of which are non-negative, and when the agent decides what to do, and I'll specify how that agent proceeds, but the agent will assume that regardless of how much the agent decides to buy, the agent can do that at the price that is quoted. Just because you buy a lot doesn't mean that the agent understands that the price will rise. Okay, so agents are price takers. Is that okay? Yeah, makes sense so far? So now what will the agent do? Well, the agent looks at his or her endowment and asks, what will I be able to obtain if I were to sell those endowments at those prices? So that's what we typically think of as the agent's income. So that would be P1 omega 1A plus P2 omega 2A, and similarly for agent B. Is it okay? So these prices identify a line. Okay. This arrow here is the normal vector to that line, so that's it's perpendicular to that line, and that perpendicular vector is given precisely by P1. Is that okay? Yeah. And now we have a budget set. We've said that the agent will consume non-negative quantities, so we are above, over there, we are to the right here, and you would imagine that the agent cannot spend more than the agent has in resources, right? So we will be below that line. In other words, I'm deliberately leaving the indifference curve over there. So that's my budget set. Is that okay? Our agent will be rational. Now rationality has various aspects to it. Okay, an important element of rationality is something called transitivity, which we're not getting into here. For us, rationality will require that the agent picks the best point in that budget set. Is that okay? There could be more than one, but since I've drawn the indifference curve, a representative one over here, so that it is strictly convex, or the upper set is strictly convex, I'm going to assume that that's the point at which the agent maximizes, which I'm drawing with a tangency, which you probably know it should be, but soon we'll see why. For the moment, you just take it as given. That's the maximizing point. What is the agent maximizing? Right? I said chooses the best point, but beyond that, now I've written maximizing, so I need to be more careful. We get to that a bit later. For the moment, think of it as there's a budget set and you choose the best point. The best or one of the best points. Okay? Questions so far? Anything that you want to ask? There will be details to be filled in, which I will do in a little later. Anything that you want to ask? Alright. So now we have two agents, and therefore I can start with Mr. A looking at the economy from there. Good 1. Good 2. Mr. A has an endowment, which is over there. Okay. Now, if I add Mr. A's endowment, please pay attention. If I add Mr. A's endowment to Mr. B's endowment, good by good, I get the total endowment in the economy. That's how much I have. So that point over there is omega 1A plus omega 1B and omega 2A plus omega 2B. We agree? We can do that? And that's the most that I can distribute in this economy, because everybody's consumption has to be non-negative for each of the goods. So I cannot distribute more than that. And therefore, I can now draw a box by putting another origin there if you wish. And this is the Edgeworth Bowley box. Bowley was another economist. Bowley's name often gets dropped. Is it okay? So we have a box. We've described individual behavior there. And now we can ask, what is an equilibrium here? So what would you want to happen in an equilibrium? Well, the agents we've said will be maximizing. They'll be choosing the best point within their budget sets. How do we get budget sets? Well, with prices. So any pair of prices will give us maximizing behavior for the two agents. At equilibrium, the behavior also must be compatible, which is to say the total amount that they demand should be exactly equal to the total amount that is available. So at equilibrium, you will have a price, you will have maximizing behavior by Mr. A, and you will have maximizing behavior by Mr. B, so that the total amount that is allocated is exactly equal to the total amount that's available. Is that okay? Since they are both maximizing, it must mean that we have a point at which, depending upon from which side you look at it, each is maximizing subject to those prices at that point. And given the way I've drawn the indifference curves, it tells you that they're mutually tangent. Is that okay? So without having written it down on the board, because I will write down a formal definition of competitive equilibrium a little later, but for this example, what we are saying is, you have two goods, each has a price, which each agent takes as one that they cannot affect. They're price takers. Given those prices, budget sets are defined. Given budget sets, each agent's maximizing behavior is defined. An equilibrium is a pair of prices at which, when each agent maximizes, given those prices, maximizes in the sense of choosing a best point in the budget set at those prices, their demands are compatible. The geometry says that you're at a point in the Edgeworth box at which you have a price line and you have mutual tendency. Okay? I also strongly suggest that you do write notes on your own. Look at what I've given you, but anything that you think needs to be added to it, please add it to it either on the notes or separately, whichever way you want. That way, it will help you understand this. Will you post a little more? All right, so far? Now, you've probably heard that competitive equilibria are efficient or Pareto optimal. Right? Loosely speaking, what it says is you cannot make anyone better off without hurting someone else. Loosely speaking, sometimes one goes directly and says, because you have a mutual tangency, it's Pareto optimal, without telling you why. Okay? So the way to remember it is Pareto optimality requires that given the resources that you have, if you can make any one person better off, somebody else must be worse. So it's not possible to make at least one person better off while leaving everybody else just as well off. That's Pareto. And we define it here. So what we see here is competitive equilibria are Pareto optimal. It requires a proof which I haven't given you. We will get to that later in a more general framework. Now, there can be more than one equilibrium. Okay, given the endowment, you can have more than one equilibrium, which I'm not putting on the board here. Under very general conditions, which are satisfied in the way I've drawn things on the board, competitive equilibria are Pareto efficient. Okay. Pareto efficiency is a minimal requirement. It basically says you don't waste resources. All sorts of allocations in Pareto. So in this economy, I could actually give everything to Mr. B and leave Mr. A at the origin. I confiscate all resources and give everything to Mr. B. Typically that will also be Pareto. So Pareto optimality really doesn't say anything about distribution. It doesn't say that you need to like the competitive outcome. It just says the competitive outcome is efficient. But there is a second result in general equilibrium, which you might have come across, which says that if you dislike the outcome that you're getting, you wish to go somewhere else, then going somewhere else is something that you can do because there will be competitive prices which will allow you to obtain the alternative allocation, which is Pareto optimal. So there will be prices, and you will have to make a tax or a transfer to each agent, just one tax or a transfer, so that their budget set shifts to the appropriate point given their endowments. So you reassign not each endowment individually, but you reassign income in a certain manner. The total reassignment is 0, so it nets out to 0. And with those reassigned incomes, you will have prices, which you already found, such that competitive behavior gets you the allocation that you want. So if you want a different allocation, which is Pareto optimal, you don't literally need to reallocate apples and bananas separately. This is the point. Remember, apples and bananas is the basic case. You could have 350,000 gurus. You don't need a central planner sitting and deciding who eats how many kinds of different apples. Okay? How many of each. What you could do in this specific perfect world is you could find, you know that if the allocation is Pareto optimal, there will be prices such that at those prices, with an appropriate transfer of income, you will be able to decentralize that space. So markets work nicely. Is that okay? Have you seen the Edgeworth box before? No? Sure? Huh? That's very, very surprising. Not even at A-level economics. That I'm not that surprised at. But first year or second year, micro, you haven't seen the Edgeworth box. This I will be taking off with some.
We've seen budget lines and
Yes.
difference curves.
Yes.
I don't think we've seen the actual Edgeworth.
You haven't seen that. You haven't even seen that in your textbooks, or you don't remember that. Might have been in the textbook, but it wasn't mentioned in class, so you skipped it. It's, you know, it's fundamental. I go so far as to say, one of the, this chap, a gentleman called Andrea Mascolel, who later became a minister in Catalonia, etc., who's one of the finest mathematical economists of the last 40 or 50 years. And I remember Mascolel saying this somewhere, not just in conversation, but also written. Just about any result in economics that's interesting, can be proved in the algebra course. So that's where you start. That's where you get your intuition. That's where you understand things. Okay? But of course, the actual world that you need to deal with, particularly when you wish to analyze things like money, requires a slightly different and more general framework where you can really see things. So this is where you need to start. Okay. It's all right if I erase that and then move on? If you want me not to erase things, you should tell me, and then I will. Okay. So now what we wish to do is set up a general framework. This is purely mathematical notation. The motivation is what we've seen, and I wish to define a bunch of things. So I'm going to look at competitive equilibrium. So we will have goods that are labeled 1 through capital L. Lowercase l will denote any one of these goods. And the set of goods will be denoted script L. Okay? What we did earlier was L equals to capital L equals to. And you will see why I've defined all three things somewhat differently, because it will help us in the notation. Once again, they're physically distinguishable by all concerned. So it's clear as to what is an apple, it's clear what is a banana, it's clear what is a pear, it's clear what is milk, etc., etc. Okay? This is what you start with. You have a set of goods. L could be any number, finite for the moment. Any number. And for the moment, I'm going to continue to assume that the goods are perishable. So the idea is, again, this economy exists in just one period. Later, we will see how the model can be reinterpreted. That's going to be the beauty of this. For the moment, the goods are perishable. And they're available for consumption in every possible quantity that is a real number, as before. Okay, you have all that in the notes, or you can write them down for yourself. You have individuals, 1 all the way to capital I. Lowercase I is a generic individual, some individual, and the set of individuals is script I. Okay? Now, it seems reasonable to say that depending on who you are, there are certain combinations of goods that you're able to consume. You might not be able to consume arbitrary combinations. So in general, you will have capital Xi, which is called individual i's consumption set. Okay, we will not be considering production here, but if you look at an economy in which people supply labor, then of course there is a restriction that you cannot supply more than 24 hours of labor, typically not more than 10 or 12. So that's a general restriction. Okay? And therefore, you would wish to allow for such things to happen. So that's a consumption set, and those are combinations of the different goods that any particular individual is actually able to consume. But given what we saw in our two-person, two-good economy, our assumption will be that once again, you can consume goods in any quantity that's a real number and non-negative. So we will assume that Xi is, and now I'm introducing notation, RL plus. So this is a list of real numbers, L of them, because we have L goods. Okay, so it's a list of real numbers, L of them. All of them are required to be non-negative. Now, instead of writing the list, why do I write it as RL plus? Well, mathematically, RL plus has certain properties which we will implicitly be using since we will be doing calculus. That's why I'm writing it. Don't really have to worry too much about that. dA. We're going to assume that each agent has an endowment, denoted omega, which sits in RL plus. Which is to say what? Notice, this says that if you decide not to participate in the economy, you can still survive. The quantities of the different goods that you have is a list which is something that allows you to survive. Okay? Xi gives you the set of consumption vectors that are feasible for you, and your endowment lies in that set. In other words, you can decide to set it for. You won't. That's a separate matter. But you can. It's a nice property of the model. You want to have such properties. You don't want to force people to trade. Over here they'll trade because they like it. It's in their interest. Okay? And agents will have preferences, which we haven't spoken about so far, other than drawing an indifference curve. And I'm not going to say very much about preferences. Okay? So preferences will be defined over their consumption set, and they will again be nice. Which is to say, more is better, technically monotone increasing. Monotone means boring, okay? But over here, it's monotone increasing, saying that more of any good is always better, and convex. Which we'd seen before, with the same idea, you take two bundles that the agent is indifferent between. The segment between those two bundles would be bundles that are at least as good as the two at the end. That's the next. Okay. And we will make a further assumption here. We're going to assume that preferences can be represented by a utility function. Which we should denote U sub I. Okay, so what is a utility function? A utility function over here, so with the representation, it says if I pick two bundles, let the first one be at least as good as the second, then there is a way of assigning numbers to each bundle such that the first bundle gets at least as high a number as the second. That's a representation. Okay? So all our properties will be based on properties of the utility function. So the utility function will be assumed to be increasing. Okay? It will assume to be quasi-concave or strictly quasi-concave, depending upon what we are doing, sometimes strictly concave. And if we require to take derivatives, then we will assume the utility function differential. Do you get that? Questions? You will not be required in any way to memorize these things and write them on an exam. I'm not going to ask you set up an economy and tell me what each element is, and you will lose marks because instead of writing here, you wrote something else. That won't happen. That's not what this class is about. Don't worry about such things. So try and understand concepts. What you have to do is work out exercises. You haven't seen any of that so far, and you won't in one of the lectures that I do. You need to understand what is happening so that you can work out very specific problems. Okay? But it's important to keep this in the background to understand where we're heading with all this. Is that all right? Yeah? So an economy now, and this is just so that we can keep track of things. An economy will be denoted with script E, and that is a list of a set of goods, a set of agents, and their characteristics. Since the consumption set is the same for everybody, we don't need to carry that separately. So you have an endowment and a utility function for each agent and that's your equilibrium. Okay? There is a competitive market for each good with the price of each good quoted per unit. So PL is the price per unit of good L in the competitive market for good L. Again, the key idea with competition is you assume that your actions cannot change the price. In the background, we are looking at economies in which all information is commonly held. There are no asymmetries of information. You don't have any advantage in knowing about various things that could affect the price any more than anybody else. Okay, that's how competition is often motivated. For us, the key idea is that you take the price as given. Okay, if the price is 3 per unit, when you demand 1 unit, the price will continue to be 3 per unit when you demand 300 million. We are not saying anything about equilibrium. We're simply saying that when you submit your demands, you take it for granted that so long as you're in your budget set, that's just feasibility for yourself, how much you demand of the good will not change the price. And we will look only at equilibrium. And at equilibrium, necessarily, it won't change the price because demands are competitive. Is that okay? Yeah? So that's competitive behavior. P, which is the list of prices, P1 through PL, is our price vector. I haven't said anything about vectors, but the reason we've written as RL plus is that elements there are called vectors, and vectors have certain nice properties, which is in the background in terms of what we are doing. We won't need much of that. Okay. Now some notation. If X and Y are vectors, I'm going to write it more generally as Rn. So these are vectors with n components. Define X dot Y to be the sum I going from 1 to n. I in the notes. J, all right. J. The jth component of X multiplied by the jth component of Y, and you sum over all j. So in the same way as with two goods, we say take the price of the first good multiplied by the endowment of the first good, and add to that the price of the second good multiplied by the endowment of the second good, would give us the agent's income. Now I would like to be able to do that with many goods without having to write them separately. So that's notation. Is that okay? For some of you who might have seen this in A-level maths or in maths otherwise, this is often called the dot product, but you don't need to know it. This is just, for us, this is just notation. Important. I's budget set, which we can now define, will be denoted script B sub I. It has to be defined at a price vector. So P, this notation says it's a definition. I seem to have used it without the dots, or write it with equality. It's the set of vectors in the consumption set, so RL plus, with the property that what you spend buying that vector is no more than the value of your endowment. Is it okay? So these are bundles or lists of quantities that are non-negative, so physically feasible, and which the person can afford to buy given the person's endowment. One last thing, and we'll stop. I have a minute, so we'll do that. The demand. Agents are rational. Which is to say they pick a best point in the budget set. And so I can define the demand set as f of I of prices P or at prices P. It's those points which are budget feasible with the property, and the property is important, that anything which is better, budget feasible and better, but I'll write it simply as better. So if Y gives you strictly more utility than that point in your budget set, it must be something that you cannot afford. Otherwise, why would you not buy it? Okay? That's your demand set. It's the set of points in your budget set such that anything that's strictly better than that, anything that you strictly prefer, you would have bought if you could. If you don't buy it, it's because you can't afford it. You certainly like it more, but it's something that you cannot afford to buy. Is it okay? This is a standard definition of maximizing behavior, written in a manner which is a bit different, hopefully clarifying what it actually is. We stop here. I'll see you tomorrow. As always, questions you can ask anytime. It will be intense for quite a while, so hopefully we get used to it. Okay, thank you.